Gentlemen and ladies, a very, very good afternoon. Welcome back to Cypher 2018's Masterclass. A quick note from our sponsors. This is our learning partner, Jigsaw Academy and the University of Chicago. Our gold sponsors, that's Analytics Labs, IBM, and ZS. Bridge Eye to Eye, Great Learning, IIDT, Insoft, Manipal ProLearn, SAP, The Weather Company, Times Professional Learning, and Unlimit, a Reliance Group company, are our silver sponsors. Our exhibit sponsors for the event are 3Lock, Analytica, BD BizWiz, Advancer, Indium, Interlens, Praxis Business School, River University, Starcom, and Wiley. Intelligent Enterprise AI, our panel sponsors, Actify Data Labs, and our dinner sponsor, Ematicus Learning. Now, gentlemen and ladies, before we begin with our next masterclass, a few pointers, that's a quick preset for those of you all. Before we begin, gentlemen and ladies, please put your hands into your pockets or into your phones, purses, or your pockets. I'm sorry about that. Anyone who's got a cell phone, please switch it on to silent so that we don't have any ringing messages. You don't want to be that guy. If you'd like to update, that is, use the hashtag Cypher 2018. You do stand to win a prize. Also, we are conducting the AI quiz that's happening in the Grand Ballroom at 4 p.m. Now, without further ado, I'd like to introduce our next speaker. He is going to be conducting our next masterclass. His name is Sohan Maheshwar. He is an Alexa evangelist at Amazon. He was a part of the Alexa launch in India, which has seen developers build over 15,000 skills in a short span of time. He has built voice-enabled experience with Alexa. His topic for today for the masterclass is building voice-enabled experiences with Alexa. Gentlemen and ladies, let's give him a round of applause, please.
Check, check, check. Yeah. Hi, good afternoon, everyone. My name is Sohan. I work in the Alexa team in Amazon, and I'm here to tell you about how you can build voice experiences for Alexa. Just quick show of hands, does anyone here own a device and an Echo device? Excellent. It's a good crowd. So today's talk, basically, I'll tell you a little bit about why I think voice user interfaces are a big deal, why it's important. I'll tell you a little bit about how it works, and hopefully I have time to maybe show you a quick code demo of how you can actually build a simple skill. Okay, so I'd like to start with a small quiz. I don't know if anyone here has been to a session I've done before, but I usually like to start with like a quiz of sorts. So, okay, shout out the answers if you know the answer, right? So does anyone know the significance of this number? What do you think is 4.54 billion years old? Shout it out. Okay, close enough. It's the Earth itself. The Earth is 4.54 billion years. Does anyone know the significance of this number? 100. Yes, that is correct. This was an easier one. The modern human is 200,000 years old. Okay, last question. 100,000 years. What have we been doing for 100,000 years? Speaking. I heard it from there. So we've been using voice as a means of communication for about 100,000 years now, right? And oddly enough, how we interact with personal tech really hasn't reflected this, right? So if you really look at how we have interacted with personal tech and you sketch that out, this is how it looks like, right? So in the mid-1970s was when it all started. Of course, people really couldn't afford it back then, but that's when you started interacting with personal technology. And we started with something called character mode, which is essentially, tiny black and white monitor and a keyboard to enter text commands. Not very different from the terminal that we use nowadays, right? But of course, far more primitive version. In the mid-80s, things changed a little bit. We moved to user interfaces, graphical user interfaces, where you could actually see a file on your computer. You could click and drag a file. What was mind-blowing back then was you could move this piece of hardware that would translate onto the screen, your computer mouse, right? That didn't exist before. In the mid-90s, we moved to the era of the web, where for the first time we could get information at your fingertips. This meant using new UI constructs like your browser, for instance. It didn't exist before. So even within your browser, you had drop-down menus, radio buttons, all these new user interfaces that really helped us surf on the web. In the mid-2000s is, I think, something we're all familiar with, right? We came to the era of the mobile phone. And in the 15, 20 years or so that the mobile has been around also, just look at how much things have changed. Right? We've gone from very basic phones with like keypads and small black and white screens to the advanced smartphones that we have in our pockets today. And just think of the sort of interactions that you have on your phone today, like swipe right or pull to refresh, or how do you zoom a page? You do that, the pinch to zoom. All these things didn't exist before, but as tech really evolve, so do how we interact with tech. So if you can see, almost every 10 years or so, there's a change in how we interact with tech. And sometime in the mid-2010s, there was a change again, and this time towards voice user interfaces, right? The ability to talk to machines and have it respond intelligently. Now, you might think, hey, we've been speaking to each other. We've been using voice as a means of communication for our entire lives. It's such a big deal. A baby's first word is such a big deal. Why didn't we just start with this? Well, the truth is it wasn't easy, right? But now we're finally at the stage where we have access to the data, we have access to the network capabilities, the data processing power, we have the machine learning algos in place. All of this has sort of come together for us to be able to really talk to machines. Right? So we at Amazon, we truly believe that voice is the next major disruption in computing. And given that we are in Bangalore, I'm guessing you guys would have heard this word a lot, disruption. It's when any new product or new platform comes into the picture and really changes how we think or operate. Right? And we believe when it comes to computing, voice is the next major disruption. What this means is you'll not only be using machines like Alexa or the Echo in your home, but also at your workplace, at the supermarket, in your car, and you'll be interacting with machines a lot more via your voice in the days to come. So we saw this disruption really, we saw this disruption happen, and we came up with this beautiful device. It's called the Amazon Echo. Again, a lot of you all have the device, but just for those of you all who might not be familiar, it's a device that you can voice control your world with. So everything from playing music to getting the news to controlling the smart home devices, a whole bunch of things, and even like a lot of social things you can do just via your voice. Right? It looks like a speaker, but it's connected to the internet at all points of time, and you can really interact with it and get intelligent responses. Now, similar to how when you buy your phone, the first thing you do, your phone can do a few things by default. You can make a call, send SMSs, take photos. What's the first thing that you do when you get your phone? You download apps, right? You'll download a WhatsApp or an Uber, etc. Similarly, on Alexa, there are a lot of things Alexa can do, and a lot of things it can help you with. But you can really enhance the capabilities of an Alexa device using something called a skill. Right? A skill on Alexa is like an app on your phone. And it's very similar, the whole concept. There is a skill store. Anyone can build a skill and publish it to the skill store as well. Right now, on last count, we have 50,000 skills globally and about 15,000 in India, which I think is a fairly impressive number given we just launched earlier this year. Right? So a lot of people sort of ask me, hey, I have my phone. Why do I really sort of need this device? Right? I think I'm happy with my phone. I really don't need this. But let's just take a look at few interactions that I think are either easier or faster or more natural via voice. Something like as simple as adding a reminder, right? On your phone, you have to do a bunch of things like actually locate your phone, unlock it, look for the appropriate app, find the right to-do list, type the name of the task, and then actually you're done. Right? I think the easier and more faster and more natural way is to just say something like Alexa, book flight to my to-do list. Right? I think it's far more natural. It takes you like a couple of seconds, and I think it just makes your life easier. Similarly, something like turning off smart home lights. Again, on your phone, it's the same old thing where you have to locate your phone, open the correct app, look for the light, and press the button for actually a light to turn on. Right? Honestly, I just prefer the old method where you could just get up and walk to the light and switch it on and off. And honestly, I think that's easier. But with Alexa, I think again it's easier, faster, and more natural by just saying something like Alexa, turn off the bedroom light. So these are just few examples. And again, I'm not saying the mobile phone's going to go away or the web's going to go away, but I'm saying that the next primary user interface will be voice, right? Just to draw an analogy, maybe 15 years ago, if someone told you the primary user interface would be touch screens, a lot of people I think would have been very skeptical about that. Right? And the reason is because we were all comfortable with the web and the desktop era back then. No one really predicted the sort of meteoric rise of cell phones and smartphones and how it would change our lives. So in the next few years, I strongly believe and we strongly believe that voice is going to be the primary user interface, and it's going to replace this whole age of smartphones very soon. So again, just to give you some other famous skills right now in India, you have like Sohan, you have Ola, you have Zomato. All the famous Indian startups have corresponding skills, so do go try them out. So someone asked me an interesting question recently, which was, hey, with phones, almost every couple of years I need to like sort of buy a new phone. When will this device get outdated? I thought that was an interesting question because honestly, if you think about it, the speaker or the device, the hardware device itself, this is pretty much an input-output device, right? All the improvements sort of happen in the cloud. And thanks to all the machine learning that's going on, you probably don't have to buy a new device ever, right? Because all the improvements sort of happen in the cloud when it comes to, understanding more data, responding more intelligently, understanding more languages, adding more skills. All of it's happening on the cloud, right? So with all the machine learning that's going through, you theoretically don't have to replace your device ever. So let's go a little technical and let's talk about how it actually works, right? And I've been using the word Alexa a lot. I've been using the word Echo a lot. Let me just define the two. Alexa is the cloud service that powers all these devices, right? Echo refers to the hardware line. Alexa can be installed on other third-party devices as well. So I know like Sonos has a speaker that is powered by Alexa, and I think Harman has one as well. So it's powered by two frameworks. One is called the Alexa Skills Kit, which is essentially if you want to create a skill, which is if you have some great content that you want other people to access on Alexa, on an Alexa-enabled device, you need to use the Alexa Skills Kit. Conversely, if you're a hardware person or you work in a hardware company and you want your hardware device to be enabled or to be voice enabled and to have Alexa on it, you need to use the Alexa voice service, right? So suppose you have built a smart toy or maybe something that sits in your car dashboard and you want people to interact with that device via voice, you need to use the Alexa voice service. So let's talk a little bit, let's go a little more deeper into the tech and see how it actually works, right? How, when you say something like, what's the weather in Bangalore, how do you actually get an intelligent response from Alexa? There's a lot of science and engineering and tech that goes behind it. Let's talk about that. So at its very core, I think building an Alexa skill or in general interacting with Alexa is very similar to an app or a website in the sense that there is a front end and a back end, right? The back end stuff remains the same, where you have programming logic, you have like a database. It's largely the same. The front end in this case, as you can see, there's no screen on this device, right? So we are used to seeing, when you say front end, associating it with something visual. But here we are in a voice-first world. There is no screen on an Alexa-based device, typically. So what is the front end? In this case, when we say front end, we typically refer to it as a voice user interface. So anything a user says to the device is the front end. So if I say something like, Alexa, what's the weather? Or Alexa, give me the cricket score, what I'm saying forms part of my front end, right? That is the user interface. So typically this is the interaction diagram for a user on the left there to talk to an Alexa device, and I'll go through each step. At this point of time, I'd like to stress on the fact that the hardware device in itself doesn't do too much, right? Like I said earlier, it sort of forms like an input-output. So it does a couple of things though. Most of the magic happens in the Alexa cloud itself, and let me explain how that actually works. So the hardware device does two things. The first one's called wake word detection, and the second is called beamforming. So you would have seen on ads, or if you have a device, that you have to start every interaction with the word Alexa itself, right? And that is called a wake word. A wake word exists because you don't want Alexa or any other device, even if you take other devices that use voice user interfaces, you don't want the device to be really processing everything that you're saying. The device needs to know when you're talking to the device, so you always start an interaction with something called a wake word, right? In most cases, it's Alexa. So the hardware device detects or waits for that wake word. Once it detects the wake word, there's something cool. It's a cool piece of hardware tech that happens. It's called beamforming, where essentially on the device itself, there are 7 really powerful microphones, right? And it's in a circular array, which means in a 360-degree arc, it can pick up sound. So what happens is it detects the source of the sound. So if the device was here and I'm standing here, the mic closest to me detects that, okay, this is where the sound's coming from. And the other mics sort of auto noise cancel themselves, right? So that way, the mic closest to the speaker forms a beam towards the speaker, forms a beam again, not an actual beam, but forms a beam towards the speaker to accurately pick up what the user is saying. This leads to something called far field recognition, where even in a crowded room like this, if everyone was chatting with each other, the Alexa device would still be accurately able to pick out when I'm talking to the device, right? And easily like 20 feet, 25 feet, you can still pick up what the user is saying. And this is possible because there are 7 really powerful microphones that can do things like beamforming. So once that's done, whatever the user says, which is called an utterance, is pushed to the Alexa cloud, which is like I said, where all the magic happens. So if I have to really simplify it, there are two things that happen in the cloud. First one is speech recognition, and the second is natural language understanding. Right? And now let's talk about each of them. Speech recognition is, I think, a problem that's been fairly solved in computer science, where you're converting speech to text. To do it with some context, though, is a little tricky, and that's what I think the Alexa cloud does really well. So let's take this example. Suppose someone says this phrase, right, and I've broken it down into its units or phonemes. It's called for t times. Right? So what could the user have potentially meant when they said this? Right? They could have meant something like 40 times, probably, doing something, a number 40 times. They could have meant for t times, a reference to chai. They could have possibly meant for t times, in the sense t off is to play golf. Or maybe there's a small, very, very small probability that 4 people want to play golf. Right? So which one did the user actually mean? So the thing is, given that they all sound the same, it's sometimes very hard to just pick up and sort of assume this is what the user said. Right? So the Alexa cloud actually does something called automatic speech recognition, where it looks at training data provided by the developer of the skill to match to what the user said. Right? That's how it's accurately able to match. So for instance, if suppose you have built a skill to do with coffee and tea ordering, right? And the developer has to provide some training data saying, hey, here's how typically someone will order tea or coffee. So the Alexa cloud can look at that training data, say, hey, this has to do with tea or coffee ordering, so the user probably meant this. Right? So that way there is that extra degree of accuracy, so that when things sound reasonably similar, it can accurately pick out what the user actually meant. All right? So that is speech to text. Once that speech is converted to text, and I think this is the key part, yeah? I'll talk about that. Yeah, so after the speech to text bit, there is something called natural language understanding. Now, for those of you all who aren't familiar or who haven't worked on it, NLU or NLP, natural language processing, sort of forms the bedrock of any conversational interface. Right? When it comes to chatbots or Alexa skills or any conversational interface, where you need to understand human conversation, which is tricky because human conversation by default is very unstructured, right? And computers can understand structured data. So what NLU or NLP algorithms do is essentially convert like unstructured human conversation into something structured that a computer can understand. And of course, I'm simplifying here, but that's what they do, right? And how they do that is two things. They find out the intent behind what the user said. Right? And by intent, I mean the meaning or the intention behind what the user said. Right? So let's take a look. So typically, this is how a user would talk to an Alexa skill. Right? So they'd say something like, Alexa, and there are a few things happening here. Right? So they'd say something like, Alexa, ask restaurant finder for breakfast. Now again, there are a few things happening here. One is you start with the wake word, which I just explained. Two is there's something called an invocation name for every skill that's built. Now again, remember that there is no screen on these devices, right? So if you have to go to a particular website, you type out the URL of the website, like you type out amazon.com. If you have to open an app, you physically click on the link of an app, right? You click on the Instagram link for it to open. In something where, in a device like an Echo device, there is no screen, so how do you really start interacting with the skill? So you can start interaction with the skill by using something called a skill invocation name. Right, where every skill has a skill invocation name, and you say that invocation name to start interacting with the skill. Right, so if you want to start interacting with the Uber skill, you'll say something like, Alexa, open Uber. Right, or you'll say, Alexa, ask Zomato for restaurant recommendations. Right. So similarly, we have taken the example of an invocation of a skill called restaurant finder, this random example. Right, and here's the operative part. Right, so you say, Alexa, ask restaurant finder for breakfast, which I think as humans we all can understand. You want recommendations for places to eat breakfast. The thing is, as humans, there are so many different ways of saying the exact same thing. Right? You can say, ask restaurant finder for breakfast, for a good breakfast place, to find places to eat in the morning, for a spot that serves the most important meal of the day. There are just literally so many other variations of the same thing, but the meaning or the intention behind each of this is the same, which is to find a place to eat breakfast. Right? So it's a job of the natural language understanding algorithm to really sort of look at some training data that you provide and then take any of these utterances and match it to a particular intent that you have defined earlier. Right? So suppose you have defined something called a recommendation intent, where you say, hey, anything that the user says related to finding a recommendation for either breakfast or lunch, it should match to this intent. That's what the NLU algorithm does. Right? So suppose someone comes and says something like, hey, I want a good breakfast place, please. You can't write an if statement to actually take all of these multiple or theoretically infinite variations. So you use a natural language understanding algorithm which actually does this for you. And the Alexa cloud does this really well. So anything to do with eating or finding a place for breakfast, it would match to a recommendation intent. Okay, so that's what an intent is. So to give you another example, can I just, so just to give you another example, let's take the example of getting weather for a city, right? So where you have something like, okay, I want the weather of this place, or give me the weather, or tell me the weather, right? These are few variations of asking for the weather. That can change to something like, is it hot outside? Is it cold outside? Is it raining outside? That can also change to something like, do I need a coat today? Do I need an umbrella today? Right? So these are different utterances. There are different ways of asking for the weather, where the intention is the same. The intent is to still get the weather, so get weather intent maybe. But there are so many different variations or utterances that a user can say to get the weather. Right? So what the NLU algorithm does is match any of these utterances that a user might say with this intent. So I've told you what an intent is and utterance is. I'm just going to tell you quickly what a slot is. A slot is essentially a variable that completes an utterance. Yeah? So any variable, something that can change within an utterance, is a slot value. So that same utterance, right? Recommend a restaurant within 4 miles. The 4 is a value that can change. Right? That can be 5 miles, 6 miles, whatever. So that is a slot value. Right? So in this case, the intent is the same. The slot value changes. Right? The slot value would be distance. So let's take another example. What if I say recommend a Thai restaurant within 4 miles? What would be the slot value? Yeah, there are 2 slots in that, so there can be multiple slots. Right? So in this case, tell me about Italian food within 4 miles. The type of cuisine can change. It can be Italian, Thai, Mexican, whatever. And also the slot value can change. Right? It can be 4 and 5. So there can be multiple slots in the same utterance. Yeah? So in this case, the distance and the cuisine would form the slots. Now, why are we doing this is because of this. Cool animation there. Essentially, if you really look at it, right, all of this complicated stuff works on a simple request-response model. Right? At the end of the day, you're getting a request here, which is a JSON file. A JSON, basically, for those who might not be familiar, is just a structured way to represent data. Right? So that JSON will have what the intent is, what the slot values are, and some other data like user ID, skill ID, etc. So you as a developer need to build a service here, and you're getting a nice JSON, and as developers that's all we need, right? And in that, once you have a nice JSON, you can figure out how you want to respond, right? Maybe you can make an API call, maybe you hit a database, hardcode some data, that's completely up to you. All you need to do is send a nice structured response back, and our SDK allows you to do that, so you don't have to worry about it. Just send a nice JSON back. It's simple JSON and JSON out. And you'll be sending it in text. And remember, we are in a voice-first world. So the Alexa cloud takes care of the text-to-speech as well. Right? And it does so using this pretty cool piece of tech called SSML, which is speech synthesis markup language. Now, SSML it's not Amazon-specific. It's a general technology. Think of it as HTML for voice, right? Where you have simple tags that allow you to make speech sound a little more conversational. Right? You don't want to sound like a computer reading out words. You'd rather add in, changes in pitch, changes in emotion, emphasis, adding pauses. All of these things you can do via simple tags. So stuff like this, right? If you just want to add a tag, you can just say add a break time tag. Very simple. It's kind of like an XML or HTML construct where you're using any markup language. If you want Alexa to say HELLO instead of hello, you can do that. You can also get it to say silly things like, bale bale or namaste or macha as well. So those are just small fun things we've added in to make your skill or make Alexa sound a little more conversational. All right? Yeah. Mm-hmm. Yeah, so there is a wake word engine on the device, which has a very, very small memory which only listens to the wake word, right? So it keeps overwriting whatever the user says till the wake word is said. Once the wake word is said, everything is pushed to the cloud. Yeah. No, it's always cloud connected. I'll take questions at the end. So let me just quickly recap what I just said. So if a user says something like Alexa, is it hot outside? Few things happen on the device. First, that signal is processed, wake word is detected, a beam is formed, and then whatever the user said is pushed to the cloud. In the cloud, a couple of things happen. The first is automatic speech recognition, where speech is converted to text. In this case, is it hot outside is converted to text. Then the NLU algorithm takes over. It has to understand the intent behind what the user said. In this case, the intent is to get the weather, right? And once that's done, it goes to your service, right? In your service, you do whatever you can, maybe make an API call to Open Weather API, get that data. You can construct like a nice JSON, send the output. The output's still in text, so you need to convert that text to speech. That's done via SSML, and what you hear is the output, which is the weather in Delhi is so and so. Right, so this is typically how Alexa works, and since this was a workshop and a masterclass, I thought it would be nice if I just show you how to build an Alexa skill, right? So maybe I'll take questions after that. I know I rushed through this a little bit, but I really want to show you the moving parts in building a skill, and honestly, it's fairly simple. So I'm going to show you a live code demo of how to build a skill. So typically a skill, can you see my screen? No. Right? So typically, like I said, there's a front end and a back end when you build your skill. There are 4 parts, if you ask me, to building a skill. Right? So you build your front end on developer.amazon.com. I'm sorry if this isn't the most clear. You build your front end on developer.amazon.com. That's where you can build the front end of your skill. You can also publish your skill to the skill store here. In your back end, you can use any service. Any service. I'll obviously show it to you on AWS, and I recommend you use AWS, but if you want to use your own, or if you want to use Azure or Firebase, that's completely fine as well. Right? So 4 steps in building a skill. Step 1, you build the front end. Step 2, you build the back end. Step 3, you just link the 2 together so that you know that when your skill is spoken to, it reaches that back end. And step 4, you can just test out your skill. Right? So let's actually go ahead and build a skill. Now, I'm going to show you the simplest of simple, like hello world skills, which is a fact skill. Right? And the reason I'm showing you this example is because there is a template readily available. But I think just to make sure you understand the working parts in the skill. Right? And it's a simple skill. It's a skill that tells you space facts. Right? So when you say something like Alexa, open space facts, which is the invocation name of the skill, and tell me a fact, it would say something about the sun or something about Mars. Again, we're doing this because the skill is readily available. So this is developer.amazon.com, where I'm building the front end to my skill. Right? I'm going to hit the create skill button. Okay, I'm going to call my skill space facts. That's easy enough. These are the languages supported right now. Right? You can see German, Japanese, Spanish, French, etc. Within English, there are like few different language models, because in different parts of the world, people speak with different accents and say different things. Right? So each language model is unique to that region. So Alexa understands English accents in India better and speaks with an Indian accent as well. Right? I'm just going to click on create a custom skill. All right. There are a couple of templates, but we're going to start from scratch. So this is the typical dashboard that you see. Just going to zoom in a little bit. Those are the 5 phases on top that you typically associate with the skill building. Right? You build your skill first. You test it out. There's a simulator online, so you can actually test out. You don't need a device to actually test out. Quick note on this, if you have a device, make sure you log in on the same ID with the device and on developer.amazon.com. That way, while you're building a skill, it's available on your device for you to test out. Okay, just quick note. Distribution is where you publish your skill to the skill store. Again, it's a similar process to how you would upload an app to the App Store or the Play Store. You just provide like an icon, some description, etc. Certification is if there is a certification process before it's live on the skill store, right? It's very similar to how Apple pushes an app to their App Store. And analytics, since we're in an analytics-focused conference, you get a lot of metrics about how users are using your skill. So things like demographics, what intents are being fired, and things like that. Okay, so I have like 7 minutes, so that's more than enough. Yeah. The first thing, like I said, is actually just giving an invocation name to your skill. Right? Remember what I said an invocation name was? That's what someone would say to start your skill. So our skill is to do with giving space facts. So I'd say something like Alexa, open space facts. Right? So that's the skill invocation name. I'm just going to hit save there. This is the operative part, right, where you have to decide what intents your skill needs, right? And the way to do that is probably to think of the features your skill would have, right? So if I was building, say, like a travel skill, like something like Go IB or Clear Trip, I'd start off with saying, hey, okay, my skill needs flight booking and hotel booking. So those would be my top two intents, right? So I'd have like a hotel book intent and a flight booking intent. So that way, anything a user says to do with booking hotels could match to the hotel book intent. Anything a user says to do with booking flights could match to the flight book intent. Suppose later on I say, hey, you know what, I need more in my skill. I need car rentals as well. I can add like a car rent intent too. So that's how you would think about what intents your skill needs. In this case, we're building a simple skill which has to do with giving facts about space. So we just have the one intent, which is like say a get new fact intent. So that's what I'm going to call it, get new fact intent. And I create that intent. Now, remember when I said you need to provide some training data, and this is where in the background all the machine learning and the AI really kicks in. You need to provide some training data about what your users would say to fire this intent. Right? So you need to put yourself in your user's shoes and say, hey, how will my users ask for facts? Right? So they can say something like maybe tell me a fact. I'll take, how can someone else ask for a fact? Tell me if you shout it out. Anybody? Maybe they can say, get me a fact, or tell me something about space. Right? So it's good practice to maybe add like 10, 12 of these utterances. This is the training data that you're providing the Alexa Cloud, right, for the natural language understanding algorithm to take over later. For the purpose of demo, I'm just giving 3 examples. So typically, if one of my users says anything to do with any of this stuff, it would match this to the name of the intent, which is here, the get new fact intent. Right? And I'll Yeah, so that's what a natural language understanding algorithm does, right? So suppose someone comes and says something like, tell me a fact, please. I've not defined it, but the meaning is the same. So that's what natural language understanding in general does. It will match it, look at this training data that you're provided and say, okay, the meaning is the same. There's an internal confidence score, and it would match to that intent. So that's how it works. So I've just saved and built that model. So that was actually step 1. I've built the front end for my skill. I'm going to step 2, which is build the back end, which I'm going to do on AWS. Right? And I'm going to use Lambda. So for those of you all, again, not familiar, Lambda is something that allows you to run code in the cloud. I think it's a great tool because I don't really have to think about scalability and downtime and stuff like that. So I'm going to create a function on Lambda, and this function serves as the backend for my skill. Right? Like I said, skill has front end, back end. I just defined the front end. This Lambda function serves as the backend for my skill. I'm going to choose a template using this thing called AWS Serverless Application Repository. Essentially, it reads from an existing GitHub page and it pulls it into a Lambda function. Right? You don't have to worry too much about it. Yeah. There is a template for a fact skill, which is why I'm choosing this particular. As you can see, it says source code URL and a GitHub page. So if anyone updates that GitHub page, it will be updated as well. And I'm just going to deploy this. So essentially what this is doing is it's looking up a GitHub link, and it's pulling all that code, and it's deploying it to a Lambda function in the cloud. Right? So that serves as the backend for my skill. Yeah, this is being created. So this is step 2, where I'm actually creating the backend. It has a hard-coded array of space facts, which is why it's easier to actually build that out. So let me just excuse me. All right. So while this is 3 more minutes, I think I'll just make it in time. Okay. So this is how your code is actually going to look at, right? And if you haven't seen Lambda before, it's pretty cool. I can actually write code in the cloud. This is in Node.js, but this is the simple code for my skill. Right? As you can see, there's a hard-coded array of facts. It's a template hello world skill. The only thing you need to know is, remember when we had defined get new fact intent? Well, essentially in my backend, I'm looking for that exact name of that intent. Right? This is how natural language understanding works, where once you match to an intent, you write code, what to do when that intent is hit, right? And this is, I'm talking about, chatbots, Alexa skill, Google Assistant, whatever. That's how it actually works. So essentially what happens is these few lines of code run when that get new fact intent is hit. It's as simple as that. And as you can see, it's just getting a random number, picking out a random fact from that array. And this is the operative bits where, I just say dot speak. It creates, I don't know if it's clear back there, but dot speak basically tells Alexa it's ready to talk. And when I say dot get response, it actually talks it out, right? So that's how it works. So now I've created my front end, I've created my back end. I need to link the two together, right? I do that with this thing here, which is called an ARN, right? I'm just going to copy that. It's a unique, it's Amazon resource name. It's a unique endpoint for this Lambda function, right? It's how like a website has an endpoint. This is the unique endpoint for my Lambda function. I'm going back to developer.amazon.com, and I'm going to paste it paste it in the endpoint menu right here, right? So this is me linking my front end and my back end together. Once I hit save, I'm done. I can test out my skill. There's a simulator in the browser, so I can just test it out there. All right. So this is the simulator. Typically, I start my skill by using the skill invocation name. So I say open space facts. Hopefully this works. Yeah.
Here's your fact. Venus rotates counterclockwise, possibly because of a collision in the past with an asteroid.
Yeah, this is a skill we just built. We can try out even some of the utterances that we gave. So remember we said something like, and tell me a fact. Let's add the word please in there. That wasn't an utterance we defined, but here's where the NLU takes over, and it figures out that the meaning is the same.
The sun is an almost perfect sphere.
Yeah. As you can see, remember I said it's simple JSON input-output. So this is the JSON input, and that's the JSON output, right? In the JSON input, you can see stuff like intent request, which is get new fact intent, which is what we define. If you had slot values, which I've not gone into, you'll see it in this JSON input as well. And I have 3 seconds left for questions. Okay, so that was typically how it would work. How you could actually build a skill. Hopefully, that was of key. If I can take like just a minute, I'll just give you my coordinates if anyone wants to get in touch with me. I've done with this. Yeah, so like I said, if for building, if your email ID is the same, it will work. If you want other people to use it, you need to publish it to the skill store. No cost. AWS costs might be there, but all this is free. The Alexa stuff is free, right? So just few links. We do a lot of workshops, hands-on workshops, which I do. You'll find those links on the first alexa.design/India. If you want to learn how to build, go to Code Academy. We also have a Slack group and a GitHub page. And yeah, just get in touch with me. That's my Twitter and email ID. So yeah, thanks. I'll be around for questions if anyone has.
Answer any major questions? No?
Do we have time? Okay. I can take maybe.
We can take one question.
Okay. Yeah, sure. Slide. Okay. I'll go ahead.
So basically, I have recently seen that there is a collaboration between Alexa and the Cortana.
Yeah.
So when the voice goes from Alexa to Cortana or the other way around, is the intent determination happens in both the places? That is one question.
I don't know actually. I honestly don't know because that's just been announced. It's not live yet, so I don't know how it's going to work. Quite honestly.
Okay. Yeah. And one more point is when there is people don't say the ask word and assume you have an Ola and Uber both, and I say, hey Alexa, book me a cab. Yeah. So which was going to hit?
Yeah. So in cases like that, it typically asks the user. So that's a good question. So if a user says, Alexa, book me a cab, it'll say, I can't help you with that, but Ola or Uber can. Which one do you want to open one of them? You have a question? Yeah. Okay. Yeah, so few things like English, it can understand depending on how much Hindi is being used. Like if you say weather kya hai, it typically picks up because of the word weather. If it's predominantly in Hindi right now, it won't understand because I think we're working on introducing few Indian languages soon where if you say something in Hindi or English, it will be able to pick up. Yeah. Right. Yeah. Yeah. Yeah, so right now, since it's English speaking, I think it's largely the tier 1, tier 2 cities. I think given the proliferation of 3G and 4G and stuff soon, people across India will have access to internet. Something we wouldn't have thought about maybe 5 years back as well. So yeah. All right, I think I'm done with
Wonderful. Let's give a round of applause, please, to Sohan, Maheshwar, Alexa Evangelist from Amazon. Now, ladies and gentlemen, just a gentle reminder on a few of our present that we have before we are continuing with the workshop as well as the master classes. If you do have a question, please raise your hand. All of us would love to hear that question and also get that answer. Okay? Now, on to our next master class.